What's going on, folks? It's Mike here, and in this lesson we're going to be continuing our C++ series and talking about passing in pointers into functions, or as we sometimes call Passbypointer, which is really still pass by value. So let's go ahead and look at exactly what we mean with an example so you can understand, again, how we pass data into functions. So again, we've been talking about pointers here, which are a data type that stores an address. So this time I want to see what happens if we pass in a pointer into a function. Now, just to recall the other strategies that we've learned about, we first learned about pass by value, which made a copy of the argument passed into a function, and pass by reference, which was just an alias for an actual value somewhere. So we're accessing and able to change that actual parameter that's passed in. Okay, so if you need a refresher on those videos are in the playlist. Go ahead and watch the pass by value and pass by reference videos. But let's go ahead and build up this pass by pointer example. And to do so, I'm going to need to start with some sort of variable here. Let's start with x equals 7, and then calling in our pass by pointer function. And I could just try to pass in the value x here, but well, what happens is if I try to run this program, I'm going to get an error. Because again, well, this argument here is just an integer. We need to pass in an address because that's what pointers store here. So that's an easy fix here. We can just put the ampersand, which gives us an address of, and then our program will compile. Now we actually want to do something interesting here. So let's actually now set the value here of our pointer by dereferencing it to 9999 here. Okay, and then if we go ahead and print out the value of x, so x stores, and let's just print out x, and a new line here, I'll recompile it, and I'm actually going to pause here for a moment and give you a chance to think about what is the value stored here. All right, so hopefully you paused and have a chance to actually look. Let's actually run our program now, and we'll see that x stores 9999. So this is kind of interesting here. So I think we'll want to explain this with a few comments. So one way to think about this is I'm calling this pass by pointer, but this is really pass by value. The difference is that the pointer stores the address of an actual memory location in our program elsewhere. So when we are dereferencing, and let me just write this here, when we dereference, and again, that's done by putting the asterisk in front of a pointer type here, which is pointer here, then we are actually changing the value in our program, wherever that memory is stored. So it might be useful if I go ahead and give us a little bit of debugging information here. And again, I'd like to do this with the address of operator. So I'm just going to put the address of x here, and let's just go ahead and print out what that value is. And I'll put an end line here, and the address of this pointer value that is passed in here. So address of the pointer. So I'll do this. But what I'd also like to do is just print out to what the actual pointer is. So we'll have the address of it, the actual pointer, and x here. And I'm going to stretch these out just a little bit so you can see everything on the screen here at one time. Okay, and let me go ahead and just line up our colons so it's a little bit easier to debug, recompile this program, and rerun it so we can see what is going on here. Okay, so just to walk through this program here, what we are actually doing here, again, creating a variable x, an integer, storing 7 in it, and then printing out the address here. That's what's right here. Now, when I pass in the address of x, remember, that's what's getting stored in this actual pointer here. And we can see that that address matches exactly what x's address is. So if we are modifying or dereferencing that address or whatever exists at that address, we must be modifying that location. Now, if you look at the actual address of this pointer here, you'll notice that it is, well, it's at a different memory location. The pointer itself is just a variable that holds an address. So that is something that is different. That is something that's a little copy, or rather a new variable that's created, and it stores the actual address of a variable. So that is how we can pass things by pointer. And in fact, C programmers don't have pass by reference. So you'll see this in your C code, or if you're using C++ with C libraries, that there's a lot of pass by pointer and there's no passing by reference. So just to be super clear, however, when I say pass by pointer, that really is pass by value. It's the same thing. It's just making a new pointer that happens to store the address of something that does exist in memory elsewhere, this X. So they're really the same thing. We're just passing by value either way. But just for clarity, and you'll often see this, folks will distinguish and say this is pass by pointer. Now, why would we use pass by pointer? Well, more often than not, you're going to see this when using C libraries, so that's where we're going to need to pass things in by pointer. Occasionally, you will also see this in C++ libraries if we need to pass in some sort of type that could change. We need to talk about polymorphism a little bit, but in general, we're going to prefer to pass things by reference. So that means just changing this asterisk to a star, and then just, again, treating this as an alias. That's going to be our preference. Again, let me make that really clear by just transforming this example back to the pass by reference. And I'll put the ampersand here and just change this value. Let's go ahead and change it to something like 42. And then let's go ahead and recall this same example here, this time just calling the pass by reference. We don't need to pass in the address, just the actual variable. And let's go ahead and fit this all on the screen here. And I'll compile, rerun, and again, you'll see this works just the same, and the address of the actual pointer, or the thing that we're pointing to, in our pass by reference example, well, you can see that's the same thing as our X here when we're printing out the address, as well as the value of this is the same. In fact, let me just make this even more clear. I don't want to call this pointer, even though behind the scenes it really is. Let me just call this ref. And just like that, I've cleaned it up so that we can just refer to this as ref, just to be a little bit more clear, since we're not passing by pointer here. Okay, let me go ahead and just run this one more time. Whoops. And make one more update there. And compile and run here. So you can see all the different values. Again, where X lives, where things live when we pass by pointer. Again, we're creating a new pointer here that stores the same address of X. The actual pointer itself is its own memory location. And then we can dereference to change the value of what is in X. And likewise, we can also, when we pass by reference here, we pass in X. We print out the value, again, which is just an alias or another way to refer to the exact same X. So you can immediately see we have that value here. We can print out the address of our when we pass by reference, which again is going to be the same value as X, and then we can simply just change it by doing 42. So now you know about pass by pointer, again, where you're going to encounter this, again, usually when using C libraries, or if you're using inheritance in C++. Otherwise, we always tend to prefer pass by reference as shown here. All right, folks, I hope that was useful for you, and you now understand how to pass pointers into function, how it's different than pass by reference, but allows us to effectively do the same thing in changing the values that we pass into the functions and preserve those values. So with that said, we'll talk a little bit more in some future lessons about passing in pointers into functions and what that really means with things like arrays and so on. So if you'd like to see that lesson, go ahead and like and subscribe so that you don't miss it when it comes out in the future. And well, if this isn't the future and the lesson's already been delivered, then, well, maybe you should just make sure you subscribe so you don't miss any of the other future lessons. Anyway, just go ahead and make sure to hit the like button, and we'll definitely see you in the next lesson. Enjoy, folks.